Good morning, everyone. My name is John Pendleton. I'm your trainer today, and we're going to be covering the heat of extraction, heat of rejection calculation, how to kind of get the information, out of the manual, how to kind of read the manual, and what those numbers kind of mean. So we'll kind of go through this here. We got some practice exercises we'll go through together, just so you can get a good feel of the heat of extraction, heat of rejection. With this calculation, it basically tells the performance of the unit. So we'll go as we go along. If you have any questions, feel free to type out your question. It's just me today. I don't have a web host, so I'll see the question. If I get to a stopping point, I'll answer your question, or we can always wait till the end. If you would like to look over this webinar again after we're through, it will be recorded, and it usually takes a little bit of time, and they'll send us a download of this recorded webinar. And then we have a YouTube channel, Enertech University, and you can go on there, and we've got a bunch of webinars. We record all the webinars right now, so you can watch any of the older past webinars, and then any that are going on now or in the future will be recorded as well. So if you sign up for a webinar and then let's say superheat and subcooling in a couple weeks, and then you decide you can't make it that afternoon, you should be able to go onto YouTube, and then you can watch it on your own time. Then if you have any questions, at the very end is my email address or tech support, and also phone numbers. So if you got any questions, if you watch one of those videos, you can give me a shout or talk to one of the guys in tech support, and we'll answer any of your questions. So this is me, a little bald-headed guy. I've been with Enertech for about almost 8 years now. Tech support, I do a lot of field visits. I've kind of switched over to the training side of things about 8 months ago or so. So I'm really focusing more on the training than tech support. But if you ever have an issue and you need to talk to me, feel free to call. The first number is my direct line, and that second number is the line to the pool in tech support. That'll ring directly to all 4 or 5 of us. Can't remember how many we got now, but and then you can just speak with who's ever the first available. You can also email me. john.pendleton@enertechgeo.com, or you can email technicalservices@enertechgeo.com. That's kind of like a group email as well. So if you have pictures or something you want to send in on something, or a video or something like that, you can definitely send it directly to me, or you can send it to the technical services at enertechgeo.com. Basically, when we're doing heat of extraction, heat of rejection, there's no refrigerant gauges needed. So that should kind of be the last resort, is to put your refrigerant gauges on there. It's a sealed system, so every time you put your gauge set on there, the hoses are going to hold some refrigerant, and over time it could become low on refrigerant, if you keep putting your refrigerant gauges on there. So we don't recommend that. Let's say the unit's out on low pressure, we don't recommend that you just immediately jump up there and throw your refrigerant gauges on there, because that can mean a whole lot of different things. But so basically it verifies the equipment performance by measuring the amount of heat that is either being rejected or extracted from the water in the loop field. So basically what you're going to need is a water pressure gauge with a needle on it, so you can insert it into a pressure temperature port or a PT port. A digital thermometer, and then you're probably going to have the IOM or the manual. If you're on the job site and you don't have it, you can go to, if it's a GeoComfort unit, you can go to geocomfort.com. If it's Hydron module, you can go to hydronmodule.com, or if it's a Techco unit, you can go to techco.com. Now, I will say, we do have those 3 brands. The units aren't any different other than the name on them. So if you went to Techco and you have a GeoComfort, it's going to be the same manual. Once you're on that website it'll have like a picture of a house and then a picture of a building, and it'll say residential, commercial. You can click on whatever type of product you have, and then it'll bring up a list with pictures of the type of unit. And you can click on that, and then you can get to the IOM, the engineering data, and any documents on that unit. If you don't have a phone, you're not capable of getting that. If you get your pressure drop and your temperature difference, you can call in tech support with the model and serial number, and we'll look it up for you, and we'll run the calculation for you and let you know how it's running. It's very important that we make sure we are always installing pressure temperature ports in the water lines, either at the flow center or at the unit. If you've got a water-to-water unit, I recommend that you put them on the load side as well. Without those, we can't really establish what flow we're moving. You know, it's not like airflow where you can just put your hand over a register or your hand over the condenser fan motor and see if it's, you know, blowing air out. With water, you know, it's in a pipe. You know, you shouldn't really, in perfect world, be able to hear it. And you can't really feel flow either. So there's also no calculation that I can give you to establish flow. That's why we've got to have the manual. That's all engineered data. And so we've got to use the manual for it. When we do heat of extraction, we do have some part load numbers in our manuals, but I would always recommend running the unit in second stage. We have heat of extraction, heat of rejection worksheets, the calculations, the refrigerant diagram in all the manuals in the back. So if you don't remember the formula or you're not real sure about it, you can look at that form and that'll kind of guide you along as well. The first thing you got to understand is the data tables in our engineering spec catalogs. So, you know, you open up the extended data charts and there's quite a bit of information there. So we'll kind of go through and I'll explain what everything kind of means here. Basically, entering water temperature is just that. It's the source entering water temperature. On this chart here in this manual, we're showing a 30, 50, and it probably went to 70, 90, and then maybe 110. The newer manuals will break it down to smaller water temperatures. So we might have 30, 35, 40, and then we might go 40 to 50 to 60 and so on. So we don't have them quite as spread apart now, but that's just that. That's the entering water coming into the unit. Basically, coming in, we put a pressure or a temperature gauge in the entering water temperature and check the temperature of that water. I will say real quick, we do have it's a Cooper thermometer that we sell, and it's got a tapered end on it, and it's real small, so it goes into those PT ports really nicely. So if you don't have one and you're looking for one, look at that Cooper. It's got a yellow case on it, and it's made by Cooper. Again, we sell it. Before we handled them, I bought mine probably on Amazon or something like that for like 20 bucks. So, but we do offer them, and I would highly recommend those. Some of the other ones where they have the wider shaft on it, once you go to try to pull it out of the PT port, sometimes the head comes off with all the wires, and then the shaft is stuck in that PT port. You got to take a pair of channel locks and grab it out of there. So I'd probably also recommend maybe putting a little bit of water-based lubricant onto it, and it'll go into that PT port a lot easier. The next is our flow rate. Now, you know, you can see it says GPM, 5, 7, and 9 in that first chart. Don't just pick one. I mean, basically, we're trying to see how many gallons per minute we're moving through that heat exchanger. So what we're going to end up having to look at is next to it is that PSI, pressure drop. So that's going to correlate to a GPM. That's why we've got to have that manual to be able to know what GPM we're moving. So there's, basically a flow rate going through. We're looking for open loop would be 1.5 GPM per ton, and a closed loop is going to be 3 GPM per ton. optimal flow. So we're trying to figure out how much water we are actually moving through that heat exchanger, which would be the water pressure drop. Now, we're not going to use feet ahead. That feet ahead is more used for sizing a pump. So sizing your flow center, if you need to know the pressure drop through the unit, in feet ahead to size the pump, and you wanted to move 7 GPM at 30 degrees, that would be 7.8 feet ahead. That's not GPM and that's not pressure drop. That's just a feet ahead for calculating pump size. Basically, water pressure drop and PSI, we're going to take I like to use this picture is actually a Dwyer gauge here, and it's a digital gauge, 0 through 100. And again, we do offer that. I'm not really sure how much it is. I know I went online before we started carrying them and bought one for somewhere around $100. And it does not come with the little needle that goes in the pressure temperature port. So you'll have to buy that needle as well. But basically, we're going to check pressure in and then pressure out and do the math on that and get our pressure difference. The pressure in should always be higher than the pressure out. If it's not, then you've got your flow reversed. We'll get to that kilowatt reading here in just a second there, Jason. When we get over to that I'll kind of explain that a little bit as well. And that kilowatts is basically, it is just the compressor though. It's basically checking the power supplied in order to get the BTUs out of the unit. So we are just looking at the compressor on that. Okay. So again, pressure in, pressure out, and do the math on it. Entering air temperature is the return air temperature coming into the unit, and we list usually a 60, 70, and an 80 on that. If you're outside some of these numbers, we do have correction factors in our manual that you can use. To be honest with you, I don't know if I've ever used those correction factors. I might use those if I run the data and we're a little bit off on our performance. I might, ask, what is your exact entering air temperature, so we can make sure it's in that range. But to be honest, I don't really use that very often. But it is available in case you are out of those ranges. Again, entering air is just that. It's the return air temperature. Again, if it's 65, these are the normal ratings here of what ARI, ISO. It's normally at 80-degree return with this in cooling and 68 in heating. But so if you're outside of those ranges, we do have this little correction factor that you can use. Again, in my 8 years at Enertech, I don't think I've ever used it. Heating capacity, that's not heat of extraction. That's not what we're taking out of the loop field. Heating capacity is a total heating capacity of the unit. And that's always going to be higher than your heat of extraction. We have what's known as the heat of compression. So basically the compressor is also adding heat to the refrigerant circuit. And so we're going to take that heat and we're going to put it into the home. Now in cooling mode, we still have that same heat. So we'll pick that heat up when we take the heat out of the home. We'll pick up the heat from the compressor and dump it out into the loop field. So heat of extraction will always be lower than your heat of rejection because of this heat of compression. Now, in this example, we're just telling you it's 10,000 BTUs, but you can actually figure out what the compressor is, how many BTUs it's outputting. And there's a calculation. It's basically volts times amps equals watts, and then watts times 3.41 equals BTUs. So, if you had a compressor, a 240 volt compressor pulling 15 amps, you can just do the math on that. You take that 240 volts times your 15 amps equals your watts, and then you multiply that times 3.41, which is a constant, and that'll give you your BTUs. Now that'll give you, let's just say it gives you a BTU rating of 10,000. The compressor is not 100% efficient, so we're not taking all 10,000 BTUs of that and throwing it into the home. We're about 95% efficient. So you'd have to take that 10,000 times 95%, which will give us 9,500 BTUs, which is actually what we'd be putting into the home. So really we would be at like 3,950 BTUs, or yeah, 39,500 BTUs, sorry. So with this number, we could actually figure out the COP on the unit, how efficient the unit is working. So if you ever have a homeowner that's complaining about high bills, we can actually run this number and figure out what the COP of the unit is. We can compare that with the unit, with the manual, and see what AHRI said, or our engineering data says it's supposed to be. And if it's pretty close, then we know it's not the unit that's causing the higher bills. Heat of extraction, again, this is what we're pulling out of the loop field. So this is what's coming in from your wells in the ground, or your horizontal loop, or from your open loop. This is what we're pulling out of the system, and this is what we're going to measure. Leading air temp is just that. It is your supply air temperature. Normally, we're about 20 to 25 degrees temperature difference from your return air to your supply. So that'll kind of give you a rough idea of where you should be when you're doing some calculations. That input, the kW, the power input, again, that's the compressor. Volts times amps equals watts. So that's what that number is. That's a kilowatt. Then you could actually take that 2.47 and multiply it times your 3.41, and then also multiply that by your efficiency of your compressor, and then that'll give us our BTUs. And then basically with COP, the calculation for it is, hang on a second, let me speed right through here real quick. BTUs supply, or BTUs delivered divided by BTUs supplied. So the BTUs supplied, to be able to create this process, is 10,000 BTUs. That's the number we're going to tell you we figured out with our amps and volts. So, and the energy delivered is the 30,000 BTUs from the loop field, plus the 10,000 BTUs from the heat of compression. So we're actually supplying 40,000 BTUs, or delivering 40,000 BTUs, and it was being generated by the 10,000. So we would take 40,000, divide that by their 10,000, and in this example, we would have a 4.0 COP. That is correct, Jason. Yes, it's the COP in the book is just the compressor electrical, does not include the fan motor or the flow center. Correct. Well, we're going to get to that here in a minute, Bob. That's the heat of extraction. I'm just we'll get to the calculation to figure out how much we're pulling out of the loop field here in just a second. Again, COP is, if we were to do just pull the numbers out of the manual, BTU output divided by BTU input. we would take this 30,200, convert this 2.47 to our energy supplied, and then we would just do the math, and that's going to give us our 3.58 COP. So basically, how do we perform the measurements and calculations in order to get what we're pulling out of the loop field? So before the system can be properly serviced or diagnosed, we have to make sure water flow and airflow are established within specs. With the airflow, it's not really that difficult. You can, if it's got a ECM blower on it, you can look at the ECM board and count the flashes, and that'll tell you how much CFM you're moving. You know, and just depending on the tonnage of the unit, you can look in the manual and kind of see how many CFMs you should be moving. Because on that ECM board, one flash equals 100 CFM. So if if you're supposed to be moving 1,240 CFM, it's going to flash 12 times and then do a little crazy flash and let you know it's getting ready to start over. So it'll tell you basically 1,200 CFM because it's not going to give like a half flash for the 40 CFM. So that'll kind of tell you how many CFM you're moving. The water flow, we're going to have to take pressure drop. Now, if you have an older flow center, maybe like a QT flow center from B&D, you will have to use a flow meter tool because pressure drop is not accurate. The newer NPE flow centers from GeoFlow, those are pretty good with pressure drop, so you should be okay there. But some of the older ones, you will have to have a flow meter tool. Yeah, well, I'm not going to get into the ductwork today. So if the ductwork's not correct, your CFMs are going to be off. So that's going to tell you that your ductwork's not real good. I just had a question, are we assuming the system is properly ducted? And the answer to that question, yes, we are assuming that it is good. So, yep. So again, here's our Dwyer gauge. The one thing I do like I want to say about this Dwyer gauge is sometimes we get into some really small units and we've got like a 1 pound pressure drop, sometimes even less than 1 pound. And so that's kind of hard to see on like an analog dial type gauge. For one, it's good. This digital pressure gauge is going to do the same thing, but they're going to bounce a little bit. And it's real hard to see that on a dial gauge, that little 1 pound pressure drop. So that's why I do really like this gauge here. Again, we do sell it now. I purchased mine before we started selling them and tested it out. It's been a pretty good gauge for me. It's got a digital screen there and you can zero it out. Again, it does not come with that needle, so you'll have to get that. And then the lower picture is that Cooper thermometer. You can see it's tapered at the end. So it really it slides into that PT port a lot easier. This older one here on top, we used to hand those out in trainings, and you go to pull it out, and that whole head would come out in the wires. So really didn't fit in that PT port so well. So basically, these are the PT ports. When in doubt, install them. We've got to have them. If you call into tech support and say, well, I don't have PT ports, the only way you're going to be able to establish flow is to either install PT ports or disconnect the outgoing line, drain it into a 5-gallon bucket, and time it and see how long it takes. Well, on a pressurized system, we can't really do that. So if you don't have PT ports, there's nothing the tech support can do to help you establish flow. They'll have to be installed. And we've got to have our flow, because if we don't know our flow, the flow can affect your refrigerant pressures and how the unit operates, obviously. It's like having a condenser fan motor. It's not operating, on a standard AC or a heat pump. If it's not working, you can't expect the rest of the system to work. So make sure we're always installing pressure temperature ports. The more, if you've got more than you need in there, it's not going to hurt anything. They're not causing, flow issues or anything like that. So just make sure we're always installing them. Over time, they will start to leak, and that's why they have a cap. So leave the cap with it. The cap's got a gasket on it as well, so you can make sure it's not dripping water. Non-pressurized, some of the older NPs and definitely the QTs, you have to use the flow meter tool and insert it into the canister and check your water flow based on the level of the float that's in the tube in the sight glass. Here is the calculation for figuring out our heat of extraction or heat of rejection. The calculation does not change for cooling mode or heating mode. In heating mode, we're just extracting from the loop field and putting that heat into the home. And in cooling mode, we're taking the heat from the home and rejecting it into the water, which in turn rejects it into the loop field. So the formula is TD times GPM times brine factor. TD is your temperature difference between your entering and leaving water. GPM, we got to have our pressure drop or a flow meter tool that would tell us our flow. So we take the PSI and convert it to GPM, and that will give us the amount of GPM. Brine factor is more of a constant. If you have antifreeze in the system, use 485. If it's straight water, so you have an open loop, or you're down in Florida where it doesn't freeze, and then just use 500. 500 for pure water. Basically, the brine factor is found by multiplying the weight of the fluid used times 60 minutes in an hour, and that's really, you don't even need to know that. Just know that we use for a constant 500 for pure water and 485 for antifreeze. Here's actually the capacity factor, if you look on the far right, of the different antifreezes, different percentages. We have methanol, ethanol, propylene glycol. Those are the three main ones that we use, ethanol, methanol, and propylene glycol, and the percentages. So really propylene glycol is 483 instead of 485, but it's close enough for what we're doing. And water is actually 501, not 500, but it's a little easier to remember 500 than it is 501. So 500 for pure water, 485 for any type of antifreeze. So again, we look at this chart in the manual. Again, we have entering water temperature, and we have 3 flow rates represented. We have 6, 9, and 12 on this unit. This is a 4-ton unit, second stage, full load performance data. So 6 GPM, if you have a 4-ton unit, that would be 1.5 GPM per ton. That's the minimum flow rate that is required for an open loop. With an open loop, the water is normally right around 50 degrees and consistent. So we can, for one, we can use less water flow due to that. And we also don't want to waste water on an open loop. So we don't want to run 3 GPM. We could, it's not going to hurt anything, but you're going to be wasting a lot more water. So the first flow rate is for an open loop. We got a question here, hang on one second. Yeah, I can, they asked if I could send the antifreeze chart. At the end, grab my email address and shoot me an email, and I will send it over to you. And that goes for anybody in this training. If you see something that you want or you need, just get my email address and email that over to me, and I'll get it sent over to you. It's not a problem. I can even, if you want, I can send over a PDF of the training as well. Just let me know whatever you need, and I'll send you some electronic copies. The next flow rate is the minimum flow rate for a closed loop, which the minimum flow rate for a closed loop is 2.25 GPM per ton. That's the lowest we ever want to see on a closed loop. The third flow rate is the recommended flow rate for a closed loop, which is 3 GPM per ton. So 3 times, this is a 4-ton unit, 3 times 4 is 12. So 12 GPM is what we want. Again, don't just go to the chart and say, I'm moving 12 GPM. We got to use our pressure drop to figure out what we're actually moving. So if we were moving 12 GPM, we should have somewhere close in this unit to 4.8 pound pressure drop. So here's a flow rate example. We've got entering water temperature of 30. We have PSI in of 40.8 and PSI out of 36.6. So then we would just do the math, and I think that's not actually 3.4, it's 4.2. But and basically we would look in that chart. If we went back, we would look and it would tell us we're moving 12 GPMs. Like, or excuse me, if it's 3.4, sorry about that, 3.2 would be pretty close. So in this example, it would tell us there was, 9 GPM. And we could be a little bit off in it, but basically pressure in, pressure out. So 40 minus 36.6 is 3.4. So if we look in this chart, 30-degree entering water temperature, 3.4 pound pressure drop would equal our 7 GPM. That 7 GPM would be the minimum flow rate for a closed loop system. Temperature difference, it's just doing math. I'm sure you guys have done temperature difference on air quite a bit. Basically, water in, water out. So in this example, we have 36.8 degree entering water temperature and 31.2. So if the water temperature is higher coming in than it is leaving, we know we're in heating mode because we're extracting heat from that 36-degree water and putting it into the refrigerant circuit. So we actually lowered the water temperature by, 6.5 degrees roughly, or 5.5 degrees roughly. And that 5.5 degrees went into the refrigerant circuit. If it was reversed, then we would be in cooling mode. We would be picking up heat from the refrigerant and taking it outside. So here's an example. It's a packaged unit. It doesn't really matter really what type of unit it is. It doesn't really change things, but we have an entering water temperature of 52.1. We're leaving at 44.9. So if we do the math on that, that tells us we got a 7.2 pound pressure or temperature difference. Normally, we're going to be, I don't know, it just depends on your flow rate, but somewhere right around, 8 degrees on a closed loop. If you got an open loop, it's going to double that almost because you're moving less flow. But anyway, we've got a 7.2 degree temperature difference. We have 52.4 PSI in and 47.6 PSI out. So if we do the math, that's a 4.8 pound pressure drop at 50 degree entering water temperature, roughly. So if we look that up in the chart, that would tell us we've got 12 GPM. So as long as we know our GPM, we know our temperature difference, we know whether it's got antifreeze or not, then we can it's just doing the math equation. You can pull out your calculator on your phone and multiply 7.2 times 12 times 485. This is the closed loop system. That tells us we're extracting 41,904 BTUs. That's just a number until we look in the manual. We've got to look in the manual for the XT at 50 degree entering water at 12 GPM. And then you can also look at the 70 degree entering air temperature line. And it would tell us that in the book that we should be moving 40,100 BTUs. As long as the number that you calculate, so this 41,900, as long as that number there is within 10% of the number we see in the manual, either plus or minus, there's no reason to put refrigerant gauges on them. The unit's doing all that it can. So we're seeing how the performance is without even looking at the refrigerant pressures. Normally, we're not going to be above, unless maybe your flow is off or something. Maybe you're not really moving 12 GPM, maybe you're moving 11 or something like that. So as long as we're within 10% plus or minus of what's in the manual, then we're okay. So we'll go through a few practice exercises together, and you're feeling a little bit more comfortable with the heat of extraction, because that's again that diagram we showed earlier with the 30,000 BTUs coming out of the loop field. This is what that calculation is doing, figuring out what we're either pulling out of the loop field or putting into the loop field. So we're going to assume that we're at 1600 CFM and obviously a full load compressor. This is the YT048, which is a packaged unit. I'm sure if you guys have installed our units before, this is probably our most popular packaged forced air unit right now. Before it was the XT, the YT is normally what you'll use for a packaged unit. Basically, we've got entering water pressure of 49 and leaving water pressure of 46. So take 49 minus 46, that gives us 3 PSI. And when you're doing these measurements and checking pressure and temperature difference, I don't care what you check first, temperature, pressure, it doesn't really matter to me. I will say I would recommend using the same gauge, whether that's a pressure gauge or a temperature gauge, for both sides. Don't use two different gauges. If there's gauges mounted already, don't really trust them. I would use one that you have in your truck that you trust and use it for both sides, the entering and leaving, whether that's temperature or pressure. That way, if your gauge is off, it's going to be off for both of them and it's pressure difference, so it's not really going to affect it so much. Because we don't really care so much about what the pressure is, we care about what the pressure difference is. So if the gauge is off by 3 pounds, it's going to be off on 3 pounds on both sides, so it's not really going to matter. So again, we have 3 PSI pressure drop. That's not GPM. So the next, we'll check our temperature, and we have 53.5 in and 44.6 out. So we just do the math, and that gives us 8.9 degrees. Now, if we have 53 degrees in and 44 out, then we're in heating mode, because we're taking heat from that 53-degree water and we're collecting it in the refrigerant circuit. So the water leaving is going out the loop field, going to pick up some more heat and bring it back in. So if you got higher water temperature in, then your leaving water, you're always in heating mode, and then vice versa for cooling. So we're in heating mode. 485 is our brine factor, because we're telling you that we have methanol in the system. So just use that 485 as your constant for any time there's antifreeze. So we had 3-pound pressure drop, and we were entering at roughly 50-degree entering water temperature. I think it was 53. So here is the chart in the manual. So we'll go down to the 50-degree mark. We had 3-pound pressure drop. We follow that down. 2.9 is pretty darn close. That's good enough for me. So that tells us we're moving 9 GPM. 2.9 pound pressure drop is equal to 9 GPM. So we know our GPM. Oh, looks like I need to scoot that over a little bit. I went to the widescreen on these, and I tried to catch some of this stuff, but I must have missed some of these numbers here, kind of transposed over top of others. Delta T was 8.9. So now we can just do the math. We run the formula. 9 GPM times our temperature difference of 8.9 times our brine factor, which, since we have antifreeze, it's 485. So now it's just a matter of doing the math. Basically 9 times 9 times 485. That's going to give us a number of 38,848. Again, that's just a number of what we're actually extracting. We need to compare it to the manual. So we'll go back to the chart. Again, 50-degree entering, 9 GPM, and I believe it said we were at 1600 CFM. So if you look at this airflow chart next to your feet ahead, it'll show either 1600 or 1790. So we'll use the 1600 and we'll follow that over until we get to the HE column. You can see the arrow there. We'll follow that down at 1600 CFM. It's telling us that we should be extracting 39.6. That means 39,600 BTUs. So we were at 38.8. At 39.6, 10% of 39.6, below that would be somewhere around 36,000 BTUs, 35,000, somewhere like that. So we're within that 10%. So yes, the unit is operating properly. There's no need to put your refrigerant gauges on there, none of that. No superheat, subcooling. The unit's doing all that it can. So it's a quick, easy way to tell performance on the unit. It's an easy way to do it. If you're out there doing maintenance on a system, it's something you can check really easily and you can just leave your gauges on your truck. And we'll go through a couple more exercises here together so you get to feel a little bit more comfortable with doing it and trying to. The hardest part, I think, for a lot of guys is just understanding the tables in the manual. We'll give you the formula, but sometimes the tables, if you don't use them every day, can be a little bit more difficult to understand. So we'll go through a couple more of these and hopefully you guys will feel a little bit more comfortable doing it. So here we've got a 5-ton unit. This is an XT, it's a package unit 2, forced air. We're gonna assume we got 1950 CFM. Again, full load compressor. And the brine on this is water, H2O. So this would be an open loop. So if we have entering water pressure of 23.5 and leaving at 21, that gives us a 2.5 pound pressure drop. Entering water temperature of 48.7 and leaving at 67.9. So in this, you can see that our water temperature entering is lower than our leaving water temperature. So what would that tell us? That tells us we're picking up heat from the home and we're putting it in or transferring the heat in the heat exchanger and we're going to reject it to the loop field. So we're in cooling mode. You also see that, the temperature difference is almost 20 degrees. And, that may seem a little high, but this is an open loop. So we should be moving somewhere around 1.5 GPM per ton compared to a closed loop at 3 GPM. Well, as you move the water slower across this pipe, it's in contact with the pipe for a longer period of time, so it transfers more heat. So that's why on an open loop, you will always have a higher temperature difference than what you would see on a closed loop because it is moving so much slower and just picking up almost double the amount of heat. But we're moving about half the amount of water flow, so it kind of works itself out. So now we know our temperature difference, we know our pressure drop, we know our mode of operation is cooling because we're at 48 in and 67 out. The brine factor for water is 500. Again, that's really 501, but 500 is the constant. That's all you got to remember. Brine factor for water is 500. If you actually look at the charts in the back of the manual, we will tell you what it is as well. If it's got antifreeze, 485. If it's got straight water, it's 500. So if you do forget, you can look at those startup sheets in the back of the manual. So we had a pressure drop of 2.5 pounds. So we've got to pull out that manual that 2.5 is not GPM, that's pressure drop. So here's the chart again. We go to the entering water temperature of 50, and we had a 2.5 pound pressure drop. So that circle needs to be moved over as well. Make a note of that real quick. So we're actually at 2.5 PSI, which here we're at 2.6, would equal 7.5 GPM, but that's pretty darn close, so we're pretty good with that. So that's going to tell us that we're moving 7.5 GPM. So we know our GPM is 7.5. Our delta T, or our temperature difference, was 19.2. So now we've got all the numbers to do the calculation. So we just run the formula, 7.5 GPM times our 19.2 temperature difference times our brine factor. Again, brine factor for water is 500. So now we just pull out the little calculator and we can do the math. That tells us we're moving 72,000 BTUs. Doesn't sound too bad. So we'll go ahead and we got to compare it with the chart. So again, we pull up this manual again, 50-degree entering water temperature, 7.5 GPM, and we are at the 1950 CFM mark. So we'll follow that over to our HR, which is heat of rejection. And it will tell us that we should be moving, excuse me, it actually needs to be moved up, 80,400 BTUs. So you're like, well, so if we're supposed to be moving, we're at 72, we're moving 80,000, it should be 80,400 BTUs. 10% of 80,000 is about 8,000 BTUs. So so 10% is 72,000. It's actually 71,000, I don't know, 900 and something. So we are actually within the 10% on this. We're right at 10%. So this is one where you're going to have to look and say, you know, why did I get called out here? Did I just get called out here to do maintenance? I'm just here to clean a filter or whatever. If it's right on that edge, you kind of have to look and see why you're there. Is it underperforming as far as it can't keep up with the home? Or are you there for maintenance? If you're just there for maintenance, my recommendation is make sure you put it on the ticket and make a note either to yourself or on the ticket that to check your heat of rejection or heat of extraction next time you're out there. So really, this one is operating within specs. It's just right on the line. So, you know, if they've never had a problem, they're not complaining about it or anything, you're probably okay. It could be that you're actually moving a little bit more GPM than what is stated here. You know, you could be moving maybe 7.8 GPM instead. So you kind of got to look at that numbers and that kind of thing and kind of decide what you really want to do on that. We got a question here. Let me see. Well, you said, are we going to do water to water? I don't necessarily know what you mean by that, because the heat of extraction, heat of rejection doesn't change because of the type of unit. It's the same calculation. It doesn't matter if it's a WT, WS, a variable speed water to water, split unit, packaged unit, it doesn't matter. It's the same exact calculation. We're always checking source water. Now we can look at, like on a water to water system, we can look at the load side, and there will be some numbers that will tell you in the manual on extended data what the water temperature, if you have a certain water temperature in, what your leaving water temperature should be. But we don't have a heat of extraction, heat of rejection calculation for the for that load on a water to water unit. So again, yes, this one is operating properly, but it's right on the edge. If you got any questions when you see something like this, you're not sure really what to do, call us and text support. You know, we've got plenty of guys to give you a hand. And you got to figure this is all we do is geothermal. So we know our systems pretty well. And, we may see something that, because we do deal with it every day, that might, be a good talking point for you or something. So definitely don't ever hesitate to give us a call in tech support. If for some reason we don't answer in tech support, you can wait and once we get off the phones, we'll get to you, or you can leave a message and we'll call you back. You can leave a voicemail. We also have a new phone system now where it will actually, if you don't want to leave a voicemail and you don't want to hold on the line forever, we have a feature where you can basically, your queue line, your position in line won't change, but you can basically disconnect from the call, and when it's your turn, we will pick up the phone and there'll be nobody there, but it will ring you back. So you don't lose your place in the queue, but you don't have to hold the phone to your ear for however long it takes us to get to you. Sometimes we do get tied up on phone calls, I've been on a phone call for 2 hours before. Now, not every guy in our department's going to be on one like that, but calls are usually somewhere between 5 and 15 minutes, I would have to guess. But occasionally we do get into some longer, drawn out problems, so we get a little bit busy. I would say probably our busiest time of the day is lunchtime. And I think, it's because you guys are taking lunch too and you got questions, but also we have guys at lunch. So we're down guys, but phones are ringing more. So it's kind of crazy how that works. But yeah, usually lunchtime is one of our busiest times of the day. So if you call between about 11:30 and maybe 1, it's going to be a little bit, it could be a little bit longer wait than normal, but we're usually real good about getting back to people within an hour. If you do leave a voicemail, we're usually pretty good about checking those. So we'll go through another exercise here. This is a YT, which is the packaged unit, and it's a 3-ton unit, and we're moving 1,240 CFM with glycol in the system, so propylene glycol. Again, it doesn't matter to me whether you check pressure drop or temperature difference first. You got to check both, so it doesn't really matter. We're going to tell you in this example, we have 18 PSI in and 15 PSI out. Pretty easy to do the math on that. You have 3 PSI pressure drop. Entering water temperature of 30 and leaving at 26.9. Now, as you guys start to go through and deal with more and more geothermals, you'll start to notice temperatures and say, well, that seems kind of low, or that seems kind of high. There's obviously more to the equation, with that 3.2 degree temperature difference, which seems low. I would say probably should be 6, 7, depending on flow, maybe even higher than that. But you can't just look at the temperature and say, yeah, we're definitely low, because we do have to look at our flow rate. But you'll start to notice things and say, wow, that doesn't look quite right. So we had 30 degree entering water temperature and 26.9 out. So we're extracting some heat out of that water and putting it into the refrigerant circuit. So in this mode, we are in heating mode. So we're in heating mode. The brine factor for glycol, again, anytime you have antifreeze, just use the 485. We had a 3-pound pressure drop, and we know our entering water temperature of 30. So now we need to look in the manual, 30 degree entering water temperature and a 3-pound pressure drop. So 3.2 is pretty close. We'll give you a little bit of wiggle room there. And that's going to tell us we're moving 9 GPM, which is the recommended flow rate for a closed loop system on a 3-ton unit. 3 GPM per ton, 3-ton unit, 9 GPM. So we got 9 GPM. We had a delta T, or a temperature difference, of 3.2. So now we'll just run the math. We'll take our 9 GPM times our 3.2 temperature difference times our 485 brine factor, or antifreeze, or whatever you want to call it, but we'll call it brine factor. So we do the math, and that tells us we're moving 13,968 BTUs. Again, that's just a number. We'll compare it with that same manual, 30-degree entering water, 9 GPM, 1240 CFM. So that would give us 22,700 BTUs is what the manual is saying that the unit should be extracting from the loop field. So we were measuring 13.9 in the books at 22.7. Obviously, we're not within 10%. So no, it's not operating properly. If I saw this, okay, so 3-ton unit, we're moving about 2/3 capacity. So we're missing about 7,000 BTUs is what we're missing. So in this, the first thing I would look at is in first stage, the unit runs 2/3 capacity. And then in second stage, the units pick up the other third of capacity. So the first thing I would look at is make sure the unit is in second stage. If the thermostat is calling for second stage, then I would probably look more towards maybe make sure that the compressor is shifting in the second stage with amp draw or something like that. But this one kind of tells me it's stuck in first stage, or it could just be underperforming as well. Could be a refrigerant issue, but it's kind of funny how it's just off by just that 1/3 of capacity. So no, at this point, you would have to move on and diagnose this one further. It may take you putting the refrigerant gauges on there, but I would check electrical stuff first and rule that out, and then put my refrigerant gauges on there. Could have a TXV issue, or it's low on refrigerant or something like that. So this one, again, not operating properly. It's not within 10%. So that's the heat of extraction, heat of rejection. Again, we do have a video, and also this webinar will be recorded for later on today. This is one of our old trainers in this video here. And again, if you need to check it out, feel free. Look in the back of the manuals if for some reason you forget the calculation, and it's on all the startup sheets. Again, if you don't know it, you don't feel comfortable doing it, if you can get me temperature difference and pressure drop in the model of the unit, then I'll help you calculate it. Anyone in tech support will help you calculate it. I mean, we run this calculation numerous times a day. So we're very familiar with it. Obviously, we're very familiar with our equipment, so we understand the engineering data tables. If you're ever hesitant, give us a call. It's a lot easier to call us when you're on the job site than it is once you get home later on in the day. So if you can, I know sometimes you'll get out there and you don't have cell service, so it makes it a little bit difficult. But if you got cell service, try to give us a call when you're on site. That way we can try to assist you while you're still there, and you don't have to make another trip. Yeah, Jim Strandland, we actually do have numbers in our manuals. He said hot water generator should be shut off when testing, and yes and no. We do have those numbers in the manuals now. Matter of fact, I think on that last slide here, let me look here real quick. Let me go back. This one here, if you look over to the far right, that's the amount of BTUs at that temperature. If the superheater was on, that's how many BTUs, 4.4 BTUs, that's 4,400 BTUs are the BTUs that the desuperheater would be robbing from the unit at that water temperature. We normally would recommend that you just disconnect it and not run it with the desuperheater on. I know like this YT unit has a switch on it, so you can just flip the switch and it turns it off. Some of the older units, you will have to take the Molex connector off the pump to disconnect the power to the pump. But we do normally say, make sure you're in second stage and desuperheater off. But if for some reason you leave it on, some of these YT manuals will let you know how many BTUs the superheater is robbing. Let me leave this last slide up here. Again, this is the bottom email address is my email address. And then we've got technical services, as well as the direct line to tech support if you need assistance with that. Jim, I'm aware that the old units don't have the desuperheater information. And with that, again, don't ever hesitate to contact me if you need some more training on anything. I can always set up a personal webinar for an hour long with your other technicians, or I can do longer too. I just like to try to keep them under an hour, or right about an hour at the most, so that you guys can get back to work. But I can piece things together for you. So don't hesitate. We're not doing a whole bunch of in-person trainings right now for obvious reasons. There are times when I might come out to a dealer, but we're not bringing anyone into Enertech right now. So, but just, if you got any questions about the training, just reach out to me. We can discuss it and figure out what works best for all of you. Make sure to check out basically all of September. I'm going to have a webinar on Wednesday mornings. So at 9 o'clock. So check out Enertech University website, or you can go to our secure site as well and link to Enertech University, and you can register for any of those trainings, and they're free. We're not charging for any web trainings at all. So, sign up. If you can't make it, you can't make it, but definitely check out our trainings, and look forward to training you guys again next week. Thanks again for joining, and have a great day. Thanks, Jason. I appreciate it. Have a wonderful day, buddy.